are constant. We don't know the rho value yet, but we know the rho is a constant, so we can get out of the integrations. So that indicates YdA equal to 0. This information tell us the locations of the neutral surface. Why I say so? Y is a distance measured from the neutral surface. So on the other side is equivalent is here. Can we just simply impose a coordinate system, which means y-axis is pointing upward, and we simply put the origin onto the neutral axis, or in this view, we can put the origin onto the neutral surface. Okay. So at least these are coordinate systems, and make the story complete. Usually, we in our textbook is this. This is a z. The longitudinal direction is x. X, Y, and Z. Okay, let me do that again. X, Y, and Z. Okay? X, Y, Z. So here we have the origin on the neutral axis. And this equation tells us is this. We take these integrations over these cross sections, and this integration is 0 when origin is on that axis. This actually tells us if from your statics, this is an equation for centroid. Right? This equation tells us this is the location of the centroid. So in other words, is this. The neutral axis will pass the centroid. So that means right now we almost solve our question. The question is this: how to determine the location of the neutral surface? Simple. You look at any cross section. You determine the centroid of that cross section. You draw a horizontal line to pass the centroid. That line gives you the neutral axis. Once you know neutral axis, you simply extend throughout the whole thing. That gives you a neutral surface. That be easy. So the issue is, given a cross section, how you determine the neutral, how you determine the centroid, and that is back to your statics. And which means here, the neutral axis, NA is neutral axis, passes the centroid. Of a cross section. Simply use this word, and we can determine the location of this one or the neutral surface. Okay, keep this in mind, and later we will use an example to demonstrate how to do the calculations. And I can tell you, the majority of your calculation will be on this part. Okay, and so now we move on to the second one. So once we now determine, then we can determine what is this value here. So we from the other, any questions? So we have is okay, let me write out here, explain. So here I want to give you a little more explanations. So here, I think so far everyone understands this equation here. And this equation, I'm saying that this equation represents is the magnitude of the small force multiplied with y. This is the magnitude of the small force multiplied with this arm that gives us the tendency in that direction, that as I indicate here. The same thing, if that is the force here, that is the magnitude of the force, and multiply with the distance y here, so that gives us the same directions of we formulated here. I want to repeat this one before I move on. So here again, this is the represent in our formulation, it means the magnitude of the stress, right? We take the magnitude of the stress multiplied with this orientation, give us the moment like this. So here in this orientation, we can plug in here, y, magnitude of the stress equal to E times y over rho. So I take away the minus sign. Otherwise, if you don't believe me, otherwise you can take the moment, the definition of the moment equal to R times F. And then we simply involve in the vector like the calculation, then we will get the same result. But I think this one will be easier. Okay, so that reason why here I take off the minus sign. Want me to repeat that again? Or fine? Okay, seems no one said, so I think should be fine. Okay, we have this one. And this is a democracy. Democracy is we have to hear the voice. If you don't have any voice, you assume that everyone agrees. Like a lot of the voting this year, have you seen read the newspapers? The borough this year have the highest the voting rate than before, right? Because more people are concerned about some topics. But anyhow, any question? Here we don't take democracy. I want to take everyone understand. Okay. So if no question, then you can see E is constant. We can take out of the integration and roll out of the integration. So right now the inside here is y squared dA equal to m. So from here you can see this will E is given, m is given, and what is this? This one again, this one y is measured from the centroid, and taking the y squared over a, basically this is the moment of inertia. We defined as I in our textbook. This is called the moment of inertia. When we talk about the moment of inertia, that is very important. This is, we have to say that is respect to certain axis. For this one is respect to the neutral axis. Okay, if we calculate the moment of inertia with respect to the different axes, that will be the different values. But here we take about this. So therefore, from here we can say EI over rho equal to m. So from here you can calculate rho equal to EI over m. What is rho? Rho is the radius of curvature. The m is the given value of the moment. Or otherwise, we can rewrite it as m over EI. And rho over this one is called the curvature. And from next time, we will practice a few examples. Before I let you go, I will let you know what is curvature. This is unloaded beam. If I apply a little bending like this is called a small curvature. Larger bending, this is bent a lot. This is called the large the curvature. So the curvature is proportional to m. Okay, but also curvature is governed by EI. EI is called the bending rigidity. If this will be the steel, then I apply the same bending that is bent, I can hardly bend because steel has a larger number of the EI. Okay? So that is we got all the equation. The bending will be go through a lot of the departed and example.